Hello friends, so today we are solving this problem under daily LeetCode problem, bitwise or of subarrays. So given an integer array R, so return the number of distinct bitwise ors of all the known empty subarrays of R. So the bitwise or of a subarray is the bitwise or of each integer in that subarray. So the bitwise or of a subarray of one integer is that integer. Obviously, the bitwise or of one is itself one. So what we have to do is we have to return the distinct bitwise ORs. For example, we can understand in this way. Suppose this is our array. Okay. So if this is our array, this has these values 1, 1, 2, 3. Now these manys are the subset of this guy, right? The sub arrays. Like we have this array, right? We have multiple arrays, sub arrays. You see here, this guy is one sub array. Then 1, 1 is also one sub array. Then this 1, 2 is also one sub array. Then we have starting from here, this is 1, 1, 2 is also sub array, right? So every integer which is inside it, that itself also is sub array, right? Every like 1, 2, 3, all of them are a sub array in itself. So it can start from anywhere, can stop anywhere, right? So you can see here these are all the subarray. Now in these subarrays, if we find the XOR of all, not XOR but OR of all of them, what then we have to find the what would be the distinct value. For example, let's say we proceed ahead in this itself. What would be the OR of this? The OR of this is this number itself 1. OR of this is 1. This also OR of this is 1 only. OR of this is 2 here, right? And here we do OR of these two number 1, 1 and 2, it would be 2. Similarly, here it would be 3. It would be 3. This would be 3. So now you can see here that many times the values are repeating like 1 or 2 or 3, right? So the distinct value would be 1, 2, 3 only. So we have to return 1, 2, 3 only. We don't have to return all the duplicate or values of these subarrays. So this is what we have to do. Now the thing is how to do that, because the one which I told you is just a kind of a brute force approach, because here we can see all the subarrays, and then what we did is we found the OR of all of them, all the numbers among them, right? Then we found that 1, 2 and 3 are the repeating everywhere. No other number is coming. So 1, 2, 3 are the three distinct numbers that are coming out of doing the OR of all these subarrays numbers. So we have to find, now this is a brute force approach, that's just for the sake of understanding I'm doing in that way. Now the thing is how can we do that, right? So you guys can observe one thing here, that a subarray could be like starting from here, or it can be go for 1, 1, or it can be 1, 1, 2, or it can start from here, like these, all of them. Yeah, these are starting from anywhere and ending at anywhere. So what we have to do here is, in this approach, we have to take care of one approach here. For example, at any ith index, okay, suppose we are at this guy. So at any ith index, we will look for the left side. Whoever is the left side element, we will check that what all subarrays are ending at here. Okay, so what we will do is we will get a set. Okay, let's say we will call it this set equal to cur set. So what we will do is in cur set we will keep the OR values of all the subarrays which are ending. Let's say if this is I, then whoever is ending at this I minus 1. Okay, so whoever is ending all the subarrays, we will keep the OR of all those values into this cur. Now you guys can understand that whoever is ending at I minus 1, all those subarrays can also include this guy, because that is also adjacent. We are creating the sub-arrays, so it has to be adjacent. So this guy, ith guy, can be included with all of them. Okay, so suppose in this cur we have 3 values, OR1, O1, O2, O3, like this, right? That means all these OR values that we have calculated till I minus 1th location, we have to do the OR with this guy, right? Because this also can be the part of all these subarrays, because these subarrays are the list of the subarrays which are ending at I minus 1 location. Okay, so in this way, whatever, so let's take the real example of it. So when we will start here, first of all, we are starting with the 0 value. Zero value is the like initiation, because with the zero value, if we do the OR of any number, it is same. So when we will start from here, we will do on the left side there is no subarray, right? So we kept here zero. So if we do the OR of this guy with one, what would be the value here? So at I equal to 0, if we do the 0 with 1, so this will give us 1 only, right? So this will give us only one value, 1, right? Now we will come to this guy, second location, right? So we have already in this car, we have this one. So what we will do is we will create a next set also, because this next set would be give us the next set of car values. So in this next, what we will do? So in this next, whatever is the I we have, let's say here we have this I equal to 1. So at I we have one value. So let's say we have added already this guy 1. Now for this one value in this, we have to do the OR with all those which are ending here, right? So ending at I minus 1, we have this curve, right? So we will do the OR with all of them. So this will give only the one value, this guy, 1, right? And the another one, this one and 1, right? So these would be the two values that we have. But because this is a set, we are interested only the unique value. So this will give us only this one, right? So in this set, now we will keep on adding them in an answer set, right? Let's say we will have a answer set also. So this would be the answer set, that every time we are making the value here. So in next, whatever is the next, that we would be adding to the curve. Okay, this value would be added to the current. For next value, we will reset this next and again start and keep on assigning this curve. So now this curve would be, we will assign this value, right? And from this curve, we will be put this or all the values into the answer variable. Now we will come here. Let's say we are reaching here at 2. Okay, so when we will come to this next would be having only 2, right? Then with this 2, we will do the this uh, or operation with this curve. So curve have right now only this one value, right? Hello friends, so today we are solving this problem under daily LeetCode problem, bitwise OR of subarrays. So given an integer array R, so return the number of distinct bitwise ORs of all the non-empty subarrays of R. So the bitwise OR of a subarray is the bitwise OR of each integer in that subarray. So the bitwise OR of a subarray of one integer is that integer. Obviously, the bitwise OR of one is itself one. So what we have to do is we have to return the distinct bitwise ORs. For example, we can understand in this way. Suppose this is our array. Okay. So if this is our array, this has these values 1, 1, 2, 3. Now these manys are the subset of this guy, right? The sub-arrays. Like we have this array, right? We have multiple arrays, sub-arrays. You see here, this guy is one sub-array. Then 1, 1 is also one sub-array. Then this 1, 2 is also one sub-array. Then we have starting from here, this is 1, 1, 2 is also subarray, right? So every integer which is inside it, that itself also is subarray, right? Every like 1, 2, 3, all of them are a subarray in itself. So it can start from anywhere, can stop anywhere, right? So you can see here, these are all the subarray. Now in these subarrays, if we find the XOR of all, not XOR, but OR of all of them, what then we have to find the what would be the distinct value. For example, let's say we proceed ahead in this itself. What would be the OR of this? The OR of this is this number itself, 1. OR of this is 1. This also OR of this is 1 only. OR of this is 2 here, right? And here we do OR of these two number 1, 1 and 2, it would be 2. Similarly, here it would be 3. It would be 3. those subarrays can, or this will give us one only. Let's say we will have a n star and keep on assigning this curve.